An analogy might be like a car, in that, well, all you need to make a car is just some like iron ore, maybe some aluminum ore, and maybe some rubber from trees or whatever. Right? I think it's synthetic now, but you have to put it together in a very specific way to create a car that is actually usable and can take you from point A to point B.
Right.
Same kind of thing for a game build. It's like, yes, we have all these raw data and code and everything, but we have to put it together in a usable way.
Yep.
So that's what we'd call a game build.
In this episode of the Fika Sessions, we meet build and infrastructure engineer Daniel Gonzalez to find out all we can about what a game build is. Hi, Daniel.
Hello.
Welcome.
Thank you.
So nice to have you here, and so nice of you to bring Fika. What is this?
Well, these are kanelbullar here in Sweden.
Yeah.
But we also have another type of fika.
You brought
don't we?
something else. Yeah, so these are the Swedish cinnamon
These are the
rolls.
Swedish cinnamon rolls.
But we have this.
Here we are.
These are the real ones.
I wouldn't say real. They're both good. They're both great. I'm not trying to start a war here. I'm not even American, so
Look at these.
Like, these are cinnamon rolls.
These are the real ones, yeah. So you actually made these and brought them.
Yes.
Gonna do a little like this.
Yeah, totally.
So that's amazing in itself.
Yeah. Honestly, my girlfriend did 75% of the work. I helped out as much as I could.
Well, you still brought homemade fika.
Yes.
Not everyone does that.
Huh.
The frosting smells so much, the cinnamon smells so much.
It's a lot of everything in there. It's a lot of sugar.
Yep.
It's a lot of good.
I can tell that.
I need the calories, obviously. So.
Yep. So you work here at Massive Entertainment as a build and infrastructure engineer.
I do.
So on a kind of a top level, we always do this every episode, but if you could just describe on a very top level, what does that mean?
So, you could say it is DevOps for the Snowdrop engine. In a slightly more detailed description would be, we do two things. We handle the builds and we handle the infrastructure required to complete those builds. Game builds need to go through to create games with the Snowdrop engine. We have a whole build pipeline set up for each of our projects, and we have a lot of infrastructure, hundreds of virtual machines that we run all of these game builds on. So that is the build and infrastructure part of the job title.
There's already so many questions in there.
I can imagine, yes. We can go into those.
But first, before we start getting into that, how did you end up at Massive Entertainment?
That's a little bit of a long story. So
that's okay.
Many years ago, I played video games. I enjoyed playing video games. I still enjoy playing video games. I played a video game called Warcraft 3: The Frozen Throne, the expansion.
We've heard of that one.
Yes, some people have heard of it. It's a little bit of an indie studio. You probably haven't heard of them.
No. The studio name, I don't know.
Yeah. Anyways, great game. I played that a lot, and I met a lot of good friends through it. One good friend, in particular, I kept up with. Her name is Amy. We became really good friends, and over time, like 10, 12, 15 years later, she actually texted me one day and told me that her sister was coming to do an exchange at my university while I was finishing up my university as well. And she asked me if I could show her sister around. And I did. I showed her around town, and one thing led to another. We started dating. So good stuff. And after a couple of years, 2-3 years, she finished school. I was also finished school. I was working for a little while as a backend developer at a cool company that does kind of like 3D visualization for mining industry. And I was working as a backend developer there, like I said. And she finished school and she applied for a master's here at Lund University.
Right.
And
like 20 minutes away from Malmo.
Pretty close.
Train,
yeah. Oh yeah. I thought you meant pretty close to Canada over there. In Calgary. Yeah. Anyways, so she got accepted, and we just agreed I would come with her, and I did, and so I didn't really want to move here without a job. So I just started applying frantically to any kind of interesting looking job that I could find. And it just so happened that Massive was hiring people with my pretty general skill set. Not exactly, but I guess we could talk about that after.
Yeah.
But it just so happened that some of my skills were quite applicable to the job that I do today.
Right.
And yeah, I interviewed with my lead, Marcus, and Damir, and yeah, really good interview. We really hit it off. Then I even they flew me in for an interview from Canada. That was only my second time in Europe ever. And then, yeah, I mean, I got a job offer. I took it. Here I am, almost 3 years later.
Yeah.
Yeah, still happy here.
Yeah, that's the thing with your background as well. You don't really come from a gaming background.
Not at all, no.
A gamer background,
Yeah.
playing games, but not a gaming
Yes, exactly.
production background. But let's start with school, for example.
Yeah.
Like, how did you get into programming and to where you are today?
So at the end of high school, I honestly didn't really know what I wanted to do at all, even slightly. I just assumed I should go to university. So I did.
Sounds relatable, yeah.
Yeah, definitely. My dad suggested economics because I guess I wanted to do a history degree initially, and he said it might be tough to find employment with a history degree, and potentially. So he recommended economics, which I guess in some ways is similar. I mean, you look at big picture stuff. And I applied for economics at the University of Calgary. I got in, I started my degree, and first year was pretty good, but then I realized I really don't like, I guess, academic economics. I really like, I guess, like in the same way as like popular science, like popular economics. Like I think it's quite interesting to just see how things, the relationship between things and incentives and how different actors behave and all that kind of stuff. But as a profession, I realized I really did not want to do that. In fact, I felt honestly, I felt pretty crappy. I was quite depressed by the end of my second year of school because I was kind of on a trajectory to do this thing that I really hated, did not like whatsoever, and I was basically on the verge of just dropping out of school. And again, having no idea what to do besides that, I was just kind of clueless. So I was very lucky to take an elective on my very last semester before I was like, yeah, I'm probably not coming back for the next year, with a Computer Science 217 course. That was a Python course. Then I was like, you know what? I want to do this for real. So I actually dropped that course and I dropped all my courses, and then I switched my major to computer science and just like restarted school.
Right.
Then I did 3.5 years. Yeah, 3.5 years of school in computer science and finished up my degree in computer science.
Before we do this episode, we sit down and we talk a little bit about what we're going to talk about. And I remember one thing you said during that pre-interview was you realized that programming was the best thing ever.
Yeah, yeah.
I really got hung up on that because you sounded really happy when you said it too.
Yeah.
So why do you think programming was the best thing ever for you, coming from economics, computer science?
So I think when I was in that Computer Science 217 course, the professor, before that, I guess obviously, like you have these huge programs like Windows and in like Office and Google Search and all these things. I mean, things that you're directly interacting with on a regular basis as a regular consumer growing up. So I have all these things, but I never really put two and two together in terms of like what you could accomplish through programming, right?
Right.
So I kind of thought, well, if I do computer science, I can make an app for iPhone or Android and then sell it and then be rich like those Silicon Valley people.
Sure.
And that's what you do. That's what computer science is for. I mean, that was my impression as a high school student coming into computer science.
Right.
Obviously not particularly like well-educated like opinion, but that was just my thoughts of it.
Makes sense.
So that professor, when I went to that course, I just took it on a whim, and it just so happened that wasn't the case. Like, I mean, there were so many interesting problems you can solve with computer science. Like, it's just so much to even get into, but it goes beyond just building apps.
Right.
I mean, of course, we're talking about games here. You're still building things. You're always building things, right? But computer science as a discipline is just so much more than that. It's really just like the science of problem solving in some ways, computationally. Um, yeah, he kind of had quite an impression on me in terms of here's this methodical approach to the world where you can represent things and solve problems with it that you can really use for anything. All the manual work, I mean, a lot of the manual work that you do every day, you can kind of just automate through programming, and it's not just. And it's, to me, I know it sounds quite like simple to say now in terms of everyone knows. Oh, of course you can learn Python or whatever. You can learn something to automate some of your manual work, great. But I had never really even considered that at the time.
Right.
So I started doing that for like everything. Some of my note taking, my backups. Like I started writing cron jobs for everything. Like it kind of went from there. That was like the little shove that I needed to see like the whole wider world of how technology was all interconnected.
Right.
Yeah. Yeah. If that answers the question, I guess.
It does.
It's a bit around the issue, but
yeah, but I think it's super fascinating. But starting to pick apart a little bit of what you talked about before, like words that's come up during this conversation. What is, for example, DevOps?
So that's a big one. So DevOps, well, it comes from the words developer and operations. Historically, so developer operations, DevOps, it kind of tries to minimize the friction between development and operations.
Right.
Historically, the developers, the people who I guess create the software, create things, want to like create their features, get their bug fixes. They want to do things quickly. They want to create features and get them out to the consumers as fast as possible, right? Because that's your job, right? But the people who have to operate these things, the software, they don't. I mean, they want stability at kind of all costs. Like their main goal is not let YouTube go down for 2 hours, right? Because if that happens, Google loses a ton of money, right?
Yep.
So they don't want amazing new features. They want stability, and it kind of comes down to that. So there's kind of like was historically some friction between those two groups. You want to create things fast and ship them fast. We want to hold stability and not ship them fast. We want to keep things stable, right?
Yep.
We don't want to release a new update on Friday in the evening because it'll be a bad weekend for everybody.
Yep.
DevOps, like I said, kind of grew as a discipline to reduce the friction between those two groups. It kind of uses a bunch of different principles to do that. So it can get as simple as automation. So there's a whole lot of, for example, just manual work that you have to do every time you create a release that you can automate through DevOps, right? There's other things like continuous integration and continuous deployment. These things alongside like testing of your code and integration tests and everything allow the developers to create their changes, create their features and their bug fixes and all the stuff they want to develop, and release them in such a way that these releases become small and quick, and if something does break, they're easy to roll back.
Right.
So you continually integrate changes and continually deploy those changes to production. That means that instead of one huge change that comes every month or something and changes everything and has the potential to bring the billion-dollar website down for hours, you release much smaller, much lower risk changes several times a day, for example, right?
Right.
And this happens almost everywhere at this point. The philosophy, I guess, kind of grew up at Google. I mean, early 2010s with they have like a book called like the Software Reliability Engineering Handbook, I think. And it's kind of brings up these concepts here. I mean, the DevOps was an idea before that, but they kind of like really solidified it into the profession of site reliability engineering,
right?
The way they do it at Google. And a lot of companies, like I think Netflix is quite famous for this, like took that and ran with it and slightly changed it in their own ways to make it, make their approach work for them, what they do. I mean, there's much more to it than just like automation and testing. DevOps as a philosophy encompasses much more than just like CI, CD, and automation. I mean, they're big parts of it, but another big part of it is monitoring. So you want to monitor and alert on problems. you want to monitor all the different metrics that you can on all your applications, particularly important things. But when you have important metrics to monitor, you want to alert when problems happen as soon as they happen to the
Right.
people who can fix these problems, right? To minimize any kind of downtime. If, for example, YouTube does go down for reasons, the person who is best suited to solve the problems that cause it to go down should probably be alerted immediately.
Yeah.
And this is in addition to the automation we just talked about. Like, I mean, if you can automatically solve these problems, if, for example, just like one of the computers that keeps it up goes down, well, let's automatically restart it and not have to alert anybody, and things are fine, right?
Right.
Even if there is a second of downtime or two, right? But we're talking in the case that something manual needs to be done, then alert the person who needs to, right?
Yeah.
So this kind of keeps stress low for everybody, right? Because are you being alerted of a problem? And to be fair, you won't be alerted when it's a catastrophic failure. You were alerted when things might become a problem, and then when they become bigger problems, and then when it's really, really bad, you get another alert. So it's not just like, if you're not getting any alerts, you're probably fine, generally, right? So you kind of iterate on this process in, is there anything that is urgent that needs my attention? If not, okay, we're probably good.
Yeah.
Let's continue to build this system and continue to automate more manual work so that we can continue doing these things.
So going from that to a game build.
Yes.
So what I think we've all heard, especially when you work in the industry, you hear the word
Yes.
build.
Mm-hmm.
What's a game build, and how is it created?
Mm-hmm. So games in general, but particularly AAA games, have a lot of assets and code and just components that are needed to be put together in a very specific way. They need to be processed and baked and all sorts of these things. They need to be processed from their raw form into something that is actually usable and can be, for example, executed as a game server or as a client that you can play for any of the games that we make.
Right.
If it's an online game, right? Even for single player games, you still need to process these textures and the animations and the meshes and everything. It needs to be put together in a specific way so that it's actually usable. An analogy might be like a car, in that, well, all you need to make a car is just some like iron ore, maybe some aluminum ore, and maybe some rubber from trees or whatever. I think it's synthetic now, but you have to put it together in a very specific way to create a car that is actually usable and can take you from point A to point B.
Right.
Same kind of thing for a game build. It's like, yes, we have all these raw data and code and everything, but we have to put it together in a usable way.
Yep.
So that's what we'd call a game build.
And how's that done?
So
now we're going on a very practical level.
yes,
But
so we do everything manually. I'm totally kidding. So one of these principles is to automate things, right? So we use something called the build system to automate this entire process. Going back to that analogy of the car, well, yes, you have to process all these ores and the rubber and everything to create the tires and, and the paint and all that good stuff. So yes, we could just have a whole team of engineers to come here every day and mine the ore, refine it, take it through. I mean, needless to say, I don't know anything about cars here, but they're making the car manually by hand every step of the way, right?
Yeah.
So that would be very inefficient because, I mean, for those reasons, right? You create a factory that creates cars and can create a pipeline of like, these people do this thing, these people do these things, and eventually you do come from maybe not necessarily raw materials, but you come from components, and then eventually the result is a car. And
right.
In fact, they're reproducible. You don't just make one car, you make multiple cars, and they just kind of keep going, right? So in this analogy, the build system is kind of the car factory that we use to create game builds. So one example might be baking voices or audio or something, that we have tons of raw audio that needs to be put into a format that the game can actually use, right? And put in the right places and all that stuff. We could manually go on a computer, do this process by running a script, and then send it to the next person who needs to do the next step. That's one way to slightly automate it, I guess, but it's still quite manual. A better approach might be to create a system that can orchestrate these processes to multiple machines, right? So if you have some sort of like intelligent system that can tell on that machine do the audio, on that machine at the same time, because there's no dependency between these things, do maybe the animations, do the nav mesh over there and the global illumination over there. We can do all these things at once if there's no dependencies between them, right? If there are dependencies, in the sense that you need to do one step before another, we'll do that. And as soon as you're done, this step, send it to the other one, right? And if we can automate this whole process, we can kind of remove ourselves from the equation and kind of just like watch as overseers from above, right? Like, aha, our things are being done, and the process is being completed, and we're getting cars in the end, or game builds. So we use the build system as this this whole overseer orchestration thing that creates our cars or our game builds from the raw assets, code, everything, right? Game builds are reproducible, so and reproducible, and I forget what the term would be, but basically for some given versions of all the assets needed to create this game build through the build system, you get a game build that is specific to those inputs. So if you use different inputs, you can actually get a slightly different game build, right? So I mean, and if you have bugs in one of them, you fix some of the changes and then rerun it through the build system to create a new game build, and now those bugs may be fixed, hopefully.
Yeah. Because you have a bunch of game builds going at the same time.
Yes,
right?
yes. We have, well, every project does minimum one, but usually several per day, right?
Yeah.
So, and we have multiple projects going. So it's, it could be, I mean, just the fact that you would have to do this manually is a good enough reason to have a build system, right? That just, it would take hours upon hours to do this for any one person, or just like man hours, person hours to get this process done. So why not just automate it to make it faster? But in addition to that, it's also extremely error prone if you are a person doing this, right? So you can run it through the build system that, I mean, is a computer, and if you configure things correctly, it is reproducible, and you will always get the same build from the same inputs, right?
Yeah.
So yeah, so there's much less error, human error involved in that process.
And this is where the Devops thing with the monitoring and the
exactly,
alerts and everything comes
So
in.
if something that we've done, for example, some human error that we've done in configuring the system has broken the game builds, the game developers are not going to be happy. Our clients, the game developers, are not going to be happy because you are writing a cool new feature and that you can't see it in the game because we messed up, right? So yes, so we want to be alerted to when problems happen as soon as they happen, and so we can fix them, right? If we can't if we can't automatically fix them, because we do have a lot of automation going that fixes these problems.
Right.
Yeah. So alerting, monitoring, it's really, really good, useful stuff.
Yeah. So how does a daily day or a regular day in the life of a build and infrastructure engineer look?
It's pretty varied, actually. This is one of my favorite things about the job, that no 2 days are really the same. I mean, sometimes you have a lot of meetings, of course, that's kind of work. Yeah. But you come in the morning, you check your emails or your Teams notifications or whatever. Do you have problems? Like, has the build system sent us alerts that need to be manually fixed? If not, okay, great. But I mean, hopefully not, right? Hopefully things are all great and we don't have to do any work. But if not, if there are problems, okay, let's investigate and fix them. And we have a fairly large team of people. It's not like everyone handles every problem. We can be quite specialized in our team.
Yeah.
But for example, I am quite heavy into the monitoring and alerting stuff that I discussed, right? So if there is a problem, the monitoring system monitors itself as well, right? So if the monitoring system fails to monitor things, I mean, it sounds a little bit redundant there, but like if there are problems with the monitoring system, it will also let us know.
Yeah.
And I check those kinds of things, right? So that's kind of one of the things you do. You check in the morning, are there any problems? If so, let's fix them, right? Or see how we can fix them, or talk to some expert who knows how we can fix these things and then hook them up with that, right? One of the best strengths of our build system, I think, is that we have offloaded having to be experts of the system, of all components of the system. In fact, I know nothing about animations or audio, video, anything like that. I'm a complete noob at all that. So we talk to the domain experts, we talk to the animation programmers and the artists and everyone, and we offload the load of configuring their stuff. They know how animations works.
Right.
They know how their art works and their textures and stuff. They know how that all works, and we allow them we give them the power to configure the build system for their components to their benefit, right?
Right.
I don't have to know how anything works because they handle that, right?
Right.
And when there's problems, they are able to solve it on their end. We just configure the system, not the specifics.
Right. Makes sense.
Yeah.
So when you don't have problems,
We don't have problems. That's not that common. But when there are no problems, so we kind of actually repeat this whole cycle, right? The whole like DevOps cycle. Like you plan changes, you create those changes, you test those changes, and then you deploy those changes. You monitor the changes to see if anything went wrong, and if so, you plan changes that fix the changes that you've made, right? The problems that you've made, and you repeat the whole process again, right?
Right.
So that's kind of what our workflow kind of goes to. We, at least like in theory, it's not always exactly like that. But say there are no problems, there are no immediate problems to fix. Okay, so let's still plan. How can we improve the system so that it runs even more smoothly, like grease the wheels kind of thing, right? Let's automate more stuff that is currently manual, right? We do a whole lot of that. So we have Jira like everybody else. We have our tickets. We say, fix this manual process. How can we improve this, right?
Yeah.
The build system itself is quite a large piece of software, so it itself can always be improved. It doesn't always make the best decisions. I mean, it has its own inefficiencies, all that stuff. So yeah, we can always improve that.
Yeah.
Which is what I mean, like there's a lot of variety. It's not just follow these steps every day. It's one day could be like, build a monitoring system or improve it or make it so it's less spammy. Another day could be like investigate why these game builds aren't working for that project because this thing keeps happening. So maybe we talk about to the domain experts like we were talking about, hey, do you have any idea why these problems might be happening? If so, we kind of just like get closer to the solution like that, right? Yeah. I mean, it's a whole lot of variety there.
Yeah. Sounds very dynamic. And
Yes. Yeah.
So what tools do you use?
Oh, this is my favorite part. So on a day-to-day basis, like our build system is written in like Python, and we use Python 3 a lot. In the standard like microservices tool set for Python. We got like your Flask and your RESTful API stuff, all that good stuff. We use Grafana and Prometheus and Zabbix as our monitoring stack that we use to both monitor the build system and like outputs of it. And of course we have like emails and Teams and all that good stuff for communication tools. Let's see, what else? I do a lot of note taking, so I mean, of course, you have your code editor to go along with your programming language, your scripting language. We write and one of the strengths of Python is the scripting capabilities of it. It's really easy to kind of come up with one-off scripts to automate this one specific manual thing I have to do today.
Right.
Very, very simple. I use like VS Code and NeoVim. I also use Emacs. Like I'm all three. I'm that kind of person. Let's see, what other tools do I use? I mean, it's just so much that it's hard to say. We have a lot of internal tools that we use, but most of our stack is open source, so we can,
Right.
pretty easy to build with that. A really nice thing is that because most of our stack is open source in terms of how we build stuff, some key parts are not, but because most of it is, it's very easy to transfer skills like to other companies or game companies, right? So I think recruiting actually helps quite a bit. It's not like you have to have experience with this specific game dev tool, and if you don't, then I mean we can't really work with it. Not that it's always like that, but for us it's so versatile. The tool set is so versatile. Basically, if you've done DevOps somewhere else, you can probably do DevOps here, right?
Right.
So yeah, it's quite easy to kind of pick up and go with it. Yeah.
So if you're sitting at home, either as a student or somebody who's already in the field, or just looking into the field, because a lot of stuff you say is really fascinating, how complex everything is put together, and sitting there at home as a budding engineer, or what practical tips would you have for me?
Get pretty decent with a scripting language like Python or Go or Ruby or something like that. Learn about these DevOps principles, like what is continuous integration, what's continuous deployment, how do they work, good software testing, like one of the to some degree, like SRE and build engineering and DevOps and all these fields, they're more. Some people think like the experience level people use to get into these is quite high. For example, some people like it's rare for people to go straight from school to do this kind of stuff. Usually you take some of the, like me, like you take some other path, you work somewhere else. You happen to gain some of these skills doing that while also learning, for example, some programming or something like that, and then come in. There's kind of two routes to get here. You can do it through the programming route or through the operations route. So as an IT administrator, sysadmin, you can gain some scripting knowledge, and then from there, the automation's kind of, you already have the infrastructure knowledge here. So let's learn how to automate this infrastructure.
Right.
So yeah, like learn some programming. Read the Google Site Reliability Engineering book. It's free, completely free, and it's really, really good. Look up everything you don't know on there. There's just so many good resources. I mean, in YouTube, there's so many good YouTube channels that are like Jeff Geerling, Tech World with Nana. They're fantastic people who clearly really know their trade and have great. They're great at teaching it too. So yeah.
Awesome.
Yeah.
You know what?
Yeah.
You want to have some?
I would love to have some fika.
Do you want the Swedish one or want the?
Oh no, you're making me choose, aren't you? Yeah.
No. We can have both.
Yeah.
We can actually have both. Maybe someone behind the camera wants some.
Yeah,
but
of
we
course.
won't let them because we'll eat them.
Perfect.
I'm gonna try yours. Actually.
Yeah, perfect. I will try
I
mine
know what
too.
these taste like.
Yes,
so.
of course. Give it a
Holy
try.
gee, this is
It
heavy.
It's thick.
This
with 3 C's.
Again, one of these things you can't feel it, but this one weighs a ton, man. Okay, all right. This is not gonna look pretty. Oh. Okay. Oh my god. I'm gonna hide my mustache behind.
Yeah, I kind of just gave up on that.
Yeah. Thank you so much for coming. It's been fantastic. Learned so much about really complicated stuff.
Thank you for having me. I
Absolutely.
hope I was able to help.
Anytime, and now let's try to finish this.
Let's do it.
Thank you very much, man.
Thank you so much for joining our Fika today. We put a bunch of useful links in the description, so make sure to check those out if you want to learn more. Also, remember to like, subscribe, and all that fun stuff you do on the internet. Until next time, take care.